with OpenFOAM, you've done a few tutorials, and teach you the kind of tools that we actually tend to use in practice. They're a little bit more sophisticated, but these are the kind of things that become your mainstay. And once you master them, they'll make you that much more suitable to work within this sector and to be working with real industrial applications. So firstly, who counts as intermediate? I say this course is for intermediate level users, but who counts as intermediate exactly? Well, as I'm referring to it here, intermediate just means you have a basic understanding of OpenFOAM, you got a little bit of experience, so you probably worked through a few tutorials, presumably you have it installed. That's probably a good clue. If you have trouble getting OpenFOAM to install or anything like that, if you can't quite run something like PowerView, probably you need to get the basics settled in first. But so long as you have a little experience, that doesn't mean that you've designed a new space shuttle replacement or something, just that you have a good understanding for how to set up a case structure, for example. So you should know what a case directory looks like. Things like this I'm going to go over briefly, a little bit, so I will mention as I do them, particular things, maybe a bit of bash scripting, that kind of thing for a terminal window in Linux, how to use that. I'll mention as I'm doing it what particular things mean, but I will gloss over them relatively quickly so that we can get to the real meat of this course. So you shouldn't worry if you haven't tried every tutorial that there is or something like that. That's absolutely fine. And then hopefully you have some experience with things like block mesh, setting parameters maybe for, when does the simulation start, what's the time step, and so on. It's helpful to know what a current number is and that kind of thing. But if you don't, that's probably fine too. Incidentally, things like the current number are not really that complicated. So it's basic things. If you've had a little bit of a try with tutorials, you're probably good. The main goal of this course is to learn about intermediate level topics. That is, the kinds of things that you use all the time in practice. Not the base level skills, the skills that are important for learning a little bit about what OpenFOAM is, but the kinds of things that people use in real life. Strangely, I don't count the ability to do calculus as intermediate level. That is, solving things on a blackboard. If you can't do complex variable theory or something like that, don't worry, that is not required at all for this course. The whole point of OpenFOAM is that we can use a computer to solve for us equations which are way too hard to solve by hand. Now it's going to be advantageous to understand what equations mean, but that's not quite the same thing. So if you have a general understanding of what differential equations are, so that for instance if I gave you a differential equation you could say, well, that bit, that's the gradient of the thing with respect to time. So it's kind of like the acceleration. It's just got m multiplied on the ends, that's the mass, etc. That kind of thing. If you can do that, that's absolutely fine, that's brilliant. Actually, even if you can't do that, probably you're still okay, but it's going to be quite useful to have that. And if you're doing this at a higher level, certainly I'd encourage you strongly to learn that kind of thing. But it's not required for the course. This also is not a course on fluid dynamics. That really deserves its own treatment elsewhere, independent of computational fluid dynamics. But we are going to use a few basic principles from it. So you should have an idea, for instance, of what the pressure is, of what the density is. You should know, for instance, that the lift experienced by an aircraft is just that component of the pressure which points normal to the direction of travel of the aircraft. So it's going this way, there's pressure experienced all over the outside, some of that points that way, that's lift. The stuff that points that way, opposite to its direction of travel, that's drag. For instance, just simple things like this. You should have a reasonable understanding of that. But this course is not a substitute for a PhD. To really understand fluid dynamics to the level where you can start your own rocket company takes years. It takes years of practice, years of reading. You need to be talking to people who really understand what they're doing, professors, your supervisors. You need to be talking to people in industry. If you're going to get paid hundreds of thousands of dollars a year, or you're going to revolutionize industry in the future, and I believe that some of you can, and some of you will, that's how it works. If you're going to be able to do that stuff, there's a lot more that has to be learned outside of what this course teaches. This is all about OpenFOAM and getting OpenFOAM to do stuff in practice. It's an excellent tool, but it doesn't replace the solid foundation that you're going to need if you're going to use this stuff in practice by yourself.